why we were choosing a commercial triple store, which is Stardog, and how the contents inside the triple store do look like, and what's the ways that we offer in order to interact with the other components inside the let's say OntoTrans ecosystem. So let me start from this slide that shows the two main components. So basically, these are OntoKB and OntoREC and how they interact. OntoKB is meant for being the knowledge base for the semantic knowledge in the OntoTrans project. So basically, it's a storage for the semantic information, and it's at the very core of the platform, the software platform. As you see here, we call it OntoKB, and the component itself, the software component, works a bit like a wrapper. For what? For a triple store. So triple store is the usual way that we use as a tool in order to store triples that represent some semantic knowledge. So any triple store basically is exposing in a standard way what we call a sparkle endpoint, which is pretty similar in the traditional database to an SQL kind of endpoint, where you can, of course, input your queries to the triple store knowledge base. And the other part that I'm showing here, maybe, okay, is the RDF triple store. Of course, there are several different possible triple stores in the market, open source product, commercial products. In OntoTrans, we decided to go with the Stardog, which is a commercial product. And in the following, I will show you something more about why we decided to go with it. Okay, that's more or less it for OntoKB. Then we have OntoREC. OntoREC, let me make a kind of a disclaimer in the sense that the title suggests something like a recommending system. But indeed, as I repeated sometimes during also the project and our meetings, OntoREC is really meant to be a front end for OntoKB. So to ease the way the final users of OntoKB and the core components are interacting with the core components. Why? Because Sparkle, of course, requires many technicalities in order to build queries and stuff like that. And so it makes it a bit difficult, the interaction, would make alone a bit difficult the interactions with the triple store. So OntoREC is meant to provide kind of pre-prepared templates in order to facilitate the interaction, for instance, between the apps and the OntoKB or any other external component and the OntoKB. By exposing what? By exposing standard full-fledged REST APIs. So very easy to use stateless APIs that everybody uses nowadays to facilitate integration of software components in large distributed systems. So that's why you see here the OntoREC component and this Fast API, which is a library that basically makes it a bit easier, the implementation of these REST APIs that then we can expose externally. Okay, so these slides elaborate a bit more on what is a triple store. Triple store is basically more technically a storage, a persistent storage of RDF-based data triples. And it's also something more in the sense that typically nowadays triple stores also offer APIs in order to manipulate such RDF data And there is also an engine, a reasoner inside these recent commercial products that can reason on the triples and let the new facts emerge as we change the knowledge base, as we add new knowledge and so on and so forth. And yeah, several products nowadays also provide this kind of reasoners. I'm not going into all the details of the level of support we provide in terms of semantics. We already had some large presentation at the beginning of the project about those aspects for those of you who are interested. So what's inside the OntoKB? I'm the last one in the morning, so I have the luck of having had someone before, like Emanuele or Jasper, who were already presenting the, let's say, general infrastructure and how we decided to design and to store the knowledge and the data in OntoTrans. So basically, the idea is that inside OntoKB, we do not want to store the raw data, basically. That's the main first message. And instead, of course, we want to store the semantic knowledge. Why? Because, of course, raw data, especially in simulations, could be tons of data. And so in order to keep viable and efficient the processing of the triple store, we don't want to weight it too much with such quantity of raw data. And in addition to that, we had already large discussions, and there are also ongoing discussions about the fact that the OntoKB definitely probably should also contain some kind of metadata. Metadata are that kind of entity that also sometimes we call mappings that help to go from the ontological description of the data down to the raw data. So as we saw in the previous presentations, that could be done through entities, and then we can decorate them through some properties or some bindings to go down to the data. And so visually, the idea is to have something like this. So we have the triple store, and we keep here all the ontological information and also the various individuals for the application. Then we do have the mappings that maps those concepts into the data models, and through the data models we go down to the actual raw data. So this is the same example which was shown by Fajar in the previous presentation. So basically, here on the right, you have the application ontology for our example. Then we have these maps to relation, and we maps that into, in this example, one specific data model, which could be an Excel file like this one. So here what we do, of course, we are mapping these labels, which are the labels of the columns in the Excel file, into those concepts. The next slide shows, of course, once we have such machinery, we may think of having multiple mappings for the same concepts. So meaning multiple data models for the same kind of data. One could be stored, for instance, in an Excel file, and other raw data instead for the same concept could come from a traditional relational database, like a SQL table. So a few words about the choice of Stardog as a backend. in the first parts of the OntoTrans project, we carefully analyzed different products, compared them, and we decided to go with Stardock for several reasons that are provided in this slide. First of all, it's a very assisted commercial product and robust in that sense. And it provides supports for many things that are needed for industrial usage and to reach the high TRL values that we want to reach in our OntoTrans project. So it actively supports this realization. It supports several all profiles and also provides some additional nice features which are not available by all similar TripleStore products, such as nice graphical user interfaces, as well as the possibility to support additional rules and stuff like that that could ease the programmability of the TripleStore itself. It typically comes with a commercial license, and there is also the possibility to have a less long-lasting trial version, but yet to start also experimenting the tool. And it's also web accessible, and so it's easy through web interfaces, through a browser to use it. How does it look like? This is the graphical user interface that shows how the ontology looks like. Of course, this is the most visual representation of the ontology, like a kind of a galaxy, if you want. But then, of course, there is also the more technical JIC text-based representation of the same data. And the all of it that I'm showing, it's accessible via web. So these are web interfaces that you can use directly through a web browser, so without requiring to install anything, basically. Let's move to OntoREC instead. OntoREC, as said before, works as a kind of a front end for the knowledge base for the OntoKB. And it exposes REST APIs. Internally, it's based on two main frameworks and libraries, which are the FastAPI web framework and the Pydantic for the support of the data models. And so to ease the generation of the data structure and their partial verification and automatic generation, let's say. And it's internally, it's based on Python, and it interacts with the OntoKB through Sparkle. Okay, so it's also kind of isolated in that sense, so it interacts a lot, but at the same time, that kind of interaction makes a bit easier to, for instance, in the future as needed, think of changing a bit the TripleStores behind the curtains so that we could interact with, let's say, not too many changes with the same OntoREC component. Okay, why? Because we are using the standard Sparkle in order to interact with it. These are examples of the APIs that the OntoREC is exposing. So indeed, as you see here, there are different kinds of sets of APIs. There are general query submission APIs that basically could accept any general Sparkle statement and then interact with the triple store Sparkle endpoint directly by, of course, by querying it with the same Sparkle statement. But then we also do have APIs for the database management, so the management of the database as a whole. So tools like Stardog and other triple stores, of course, allow to isolate the different databases inside. So these APIs allow to create new ones or modify existing databases. As well, we have namespace management APIs. So for these two sets of APIs, of course, sometimes they are a bit more dependent on the specific triple store. So for these two APIs, the idea is that the OntoREC front end exposes a standard API internally in the OntoTrans ecosystem, but then could translate that, let's say, generic API into the set of instructions that must be given to the specific triple store. So in the case of Stardog, for instance, of course, the instructions to give to, for instance, create a new database are different from the ones that we would give to a different triple store like a GraphDB or something like that. Okay, so these APIs are general enough not to be changed when we change the triple store behind the curtains. As for the Sparkle interaction, instead, of course, it remains what I said before, so that's more standard. And so, of course, it's easier also the interaction with different triple stores. Oops. Okay, now some more details about how we implemented we realized the deployment and the deployment of these components. So nowadays, of course, the usual way to deploy things is through the usage of microservices, which are typically implemented as containers. So yeah, not all of us, I also realized that discussing with some of you yesterday, are so technical. So containers, let's say, that are a super easy way to distribute software, say it in few words. So, and the word containers somehow suggests the idea that containers are self-contained and standard, as the physical containers are. So the idea is that it is no more a configuration nightmare. There are no more excuses for delaying things due to configuration, because containers can ease and effectively ease the deployment of the software. So you basically just take your container, and the container comes with some information that allows just to throw that container into a machine, and then it runs, basically. The additional information are those ones contained in what it is called in the case of this implementation, which is the standard implementation nowadays for the execution of the containers at the lower system levels, are the Docker files. So basically, Docker is an implementation of this idea of supporting containers. Of course, there is much more. Containers should be also supported at the operating system levels, but we don't have the time to go into the details of that. But my point is that with these two files, plus, of course, the software that implements OntoREC and OntoKB, anybody could, at home, just throw those two containers and they run on the machine. So it's very easy. Also for those companies that we discussed that a lot during these days, don't want, of course, to open their firewalls and stuff like that. It's fairly easy for them just to bring home these two containers and then start playing with the OntoTrans ecosystem. And of course, this is something that we provide for the core components, but also for any other component, as yeah, all of you involved in the project know. Few more words about other details. We also worked on a package developed by Syntef, which is called Tripper. We were talking about this also yesterday a bit. The idea of Tripper is to have a Python interface to interact with different repo stores. And so, for instance, to ease and simplify those kind of operations that are not so standard, let's say, as the one I was mentioning before for the database creation, for the namespace management, and so on and so forth, providing a generic Python interface. So let's say more or less the same story that I told you about the REST APIs, this time with the Python interfaces. Okay. In this Tripper package, we worked with Syntef to add the support for OntoKB, which means eventually for Stardog. So to make it possible to, using the same Tripper front end, move, for instance, from Stardog to GraphDB or to Fuseki, which are other Tripper store implementations. And this is the idea, of course. So now OntoREC has been evolved to, again, expose the standard APIs, but then internally it uses Tripper. So we also do have this kind of flexibility to more easily move through Tripper from one Tripper store to one another. Okay. And externally, for the other components, they don't see any change, basically, because we still expose the same APIs we were exposing before. So how do we assess the OntoKB? There are two different possibilities. Of course, one is the one that I was telling you through the OntoREC and so through the REST APIs that we offer. And along the way, we also worked together with Syntef to integrate the so-called OT APIs and OT libs. So the idea is that following this kind of framework and implementing and verticalizing it for our needs, we were able to accordingly develop some components that are, again, at the end of the day, containers, so very easy to deploy and to configure and operate at the client side. And the processing in this case is no more only stateless as in the case of the REST APIs, but we could have some processing that are more stateful. So basically, by using these pipelines and components, it's possible also to cache some data, to locally have some contextual information, and so on and so forth, that allows to make some more complex kind of operations. So internally, for instance, the OntoREC could do something more than just expose an API and taking that query, just pushing it directly to the OntoKB. It could, for instance, cache some data and avoid to interact again with the OntoKB if the data are already there at OntoREC. Okay, just to make a simple example. Yeah, and indeed, this is an example of that. So we implemented what we called an OntoKB plugin, which is using the OT API and the OT libs, in particular also the OT libs, in order to query the knowledge base, then storing some data, then possibly once we modify that soft state, which is maintained at the OntoKB plugin premise, to push it back to the permanent repository database. Okay, so to update, for instance, the data there. Of course, this kind of stuff are pretty much diffused in the world of distributed system and more traditional, let's say, relational databases. And the data storage, let's say non-semantic based data storage. An innovation in this project is that we are applying the same concept, let's say, to a semantic-based world. That's something that I think should be emphasized. So, in conclusion, OntoKB and OntoREC allows to support the management of the ontological part of the information that we need in OntoTrans by providing a large support through standard ways that include the usage of REST APIs, the usage of containers, plus for the data storage and management, also the possibility to have an additional, I like to think about it as an additional caching level, which is also outside and it's provided through the interaction with the OTE machinery, including the OTE API, the OTE libs, and the Tripper as well. Okay, I would say that's it.